Hi guys, Dr. Diaz here again. Now we're going to discuss the ellipse. And the definition of ellipse is the set of all points P in a plane, the sum of whose distance from fixed point F1 and F2 is constant. And actually, I think when you were in school, they told you how to do an ellipse. You usually put like two knobs or nails or whatever, and then put a string around those things, and you start crossing around with a pencil. It's kind of neat. And actually, ellipse is an interesting geometric figure because it was used also to describe the motion of planets. Their orbits around the sun is actually elliptical, not circular. Circles in those times, I would say the Greek times, and all the way up to the 1400, it was almost taken as a divine object. Only divine people, they say, well, divine people, no, they say divine divinities, gods can see what's a circle. We mere mortals, we only can try to get the best thing we can do a circle, but in the past they thought a circle was the perfect or divine geometric figure. And until the 14th and 16th and 17th, 14, 15, 16, 1700, Galileo, Copernicus, Kepler, they all figured out that the orbits of the planets shouldn't be circular. Well, Copernicus was actually Kepler. It should be elliptical with the sun in one of its focus. Okay, here the equation of an ellipse. Look at this one. It says x squared divided by a squared plus y divided by b squared. If a is bigger than b, then the ellipse is going to be a line along the x-axis. And in this case, a bigger than b, but a is with the y squared, then the ellipse is going to be a line along the y-axis, right? When it's with x and a is bigger than b, it's a line along the x-axis. The other way around, when a is with y, is a line along the y-axis. Where this point a and negative a, well, let's say a0 and negative a and 0 is the vertex, and the focus c and 0, well, and the other one with minus c and 0. The same thing happens here. Here's one, here's the other one, right? This is semi-axis major, semi-minor axis. And what we're going to do is try to solve some problems. See you in a second. Hi guys. Okay, here we have the example. 4x squared plus 25y squared is equal to 100. Of course, this one does not look like an ellipse, but actually it is an ellipse. What we have to do is, when we have an equation like this one, let's rewrite it here. 4x squared plus 25y squared is equal to 100. What we had to do is we had to write it in the form like the x squared divided by a squared plus y squared divided by b squared equal to 1. So that means we have to divide everybody by 100 in order to get the 1 here. So we divide this one by 100, this one by 100, and this one by 100. And doing that, we will get that this one is going to be x squared divided by 25 plus y squared divided by 4 is equal to 1. Now we see that this ellipse is centered around the origin, but look here, 25 is bigger than 4 and 25 is with x. So what we do here is a squared is equal to 25. So that means that a, what's the square root of 25? 5. Well, we can say it's plus or minus 5. This one, b squared, is going to be equal to 4, so b is equal to plus or minus 2. So what we do here is we put this one. When x, actually the vertex is going to be when x is 5, y is 0, and when x is negative 5, y is 0. So here we have one. When x is 5, y is 0. When x is negative 5, y is 0. And this is for the semi-major axis. For the semi-minor axis, this will be when x is 0, y is 2. When x is 0, y is negative 2. And here we have our ellipse. It looks something like this. Okay, yeah, I know I'm drawing this one awful. It looks like a potato again. Suppose that is an ellipse. It looks elliptical very nicely. Oh, that one. That's what I'm supposed to do. Let me go. There it is. There you have your ellipse. If you want to calculate the focus, there's another equation you can use to calculate the focus. Oh, yeah, here it is. See, the focus is defined as c squared is equal to a squared minus b squared. And what we have to do is take, well, c, which is going to be the square root of a squared minus b squared. Well, we assume that a is bigger than b, so it's never going to be negative. So in this case, it's going to be the square root of, we have 25, because that's a squared, minus 4, because it's b squared, so it's going to be the square root of what? 21. So the square root of 21, that is approximately 4.6. So where's the focus here? Well, you put here when x, well, will be 1 is when x is 4.6 and 0, and minus 4.6 and 0. So it's going to be here 4.6 and negative 4.6. Somewhere here's the focus. Okay, and we know this is the vertex, which would be when x is negative 5, y is 0, and here the vertex will be when x is 5, y is 0, and this is semi-minor axis will be x0, y is 2, and this one will be x0, y negative 2. Okay, guys, that's all for now. Let me see if I can do another example of ellipses that is not necessarily aligned with the origin. See you guys. Oh, actually, the PowerPoint has an example of that one. Check the PowerPoint with that one. It'll give you an idea how to do these examples. The ellipses center at HK. And you will see it's not that difficult. Okay, guys, we will go to the next geometric conic section, hyperbolas. See you then.